Question 9 is asking us to solve for x in this equation here. So I'm just going to rewrite it down below. What we have is log of x minus 3 plus the log of x plus 4 minus the log of x equals log of 5. And so what we want to do with this equation here is combine all our terms with x in it, and we can do that by remembering our log rules. So the first thing I want to do is combine this first term and the second term, because what we have is two terms with the logarithm of the same base, and we're adding them. So what we can do is combine that to one logarithmic term, the same base, where we multiply the terms we're taking the logarithm of. So that's the log of x minus 3 times x plus 4. And we have this log minus log x on the outside, and that equals log 5. And so here we have two logarithmic terms with the same base, and we're subtracting them. So what we can do is combine that into one term where we divide. So I have x minus 3 times x plus 4 on the top, and I'm dividing by this x here because we're subtracting the logarithmic terms. That equals log 5. So if we look at what we have here, we're saying the logarithm of this term equals the logarithm of 5. So therefore, this term here must equal 5, and we can get rid of the logs on both sides of the equation. So this leaves us with, ignore that, leaves us with x minus 3 times x plus 4 over x equals 5. And it's important to note that we can only do this thing of canceling out the logs because we have only one term on either side of our equation. So we couldn't do that at the beginning where we have a log in each term because we're adding and subtracting the terms from each other. But if everything's combined into multiplication and division, and there's only single terms on either side of the equation, you can perform this trick. So now we have this relatively simple equation, and we can solve for x in this. So first thing I'm going to do is multiply both sides of my equation by x. That gets rid of this x on the bottom here, and we're left with x minus 3 times x plus 4 equals 5x. And next I'm just going to multiply out these brackets. That gives us x squared plus 4x minus 3x minus 12 equals 5x. So combining like terms, positive 4x minus 3x is positive 1x, minus 12 here, 5x. And I'm going to subtract 5x on both sides of my equation. This gives me x squared minus 4x minus 12 equals 0. So on the left side of the equation here, what I want to do is factor this out. So if we look at what we have here, we want something that adds up to -4 and multiplies to -12. So that ends up being x minus 6 times x plus 2. And you can try foiling this out, make sure it works out to x squared minus 4x minus 12. But this is going to let us figure out some values for x. So if we're multiplying these two terms and it equals 0, either this first term has to equal 0 or the second term has to equal 0. So if the first term equals 0, what we get is that x equals 6. The second term equals 0. What we get is x equals -2. So we have two possible answers for x. But what we have to do is look back at our original equation that we started with, which is this one up here, and see if there's any restrictions on what x can be equal to. And so if we look at this, we have logarithmic terms, and we know that you can't take the logarithm of 0 or a negative number. So that means that whatever's in each of these brackets has to be greater than 0. So this first term here, x minus 3, has to be greater than 0. Second term, x plus 4, has to be greater than 0. And x itself has to be greater than 0. So we can see from these restrictions here that x minus 2 isn't going to work out. X has to be greater than 0. So that's not a possible answer for us. But x equals 6 will make all of these restrictions true. So x minus 6 is our answer for question 9. Sorry, x equals 6 is our answer to question 9.